Hello and welcome to this tutorial on solutions. I'm calculating mole concentration and volume using this simple triangle. These calculations are used in the higher chemistry course. So what we're going to do is we're going to look at these relationships here and how we can use them for calculations and solving problems. So let's just remind ourselves of what these NCV stands for. So we've got N as being number of moles. So top here, so N is number of moles. We have C as being concentration in moles per liter. So that's mole per liter, and we have V as being volume in liters. Okay, so we just put that as liters. Okay, so let's go and have a look at some examples. Okay, so in this neutralization reaction here, we've got 25 centimeters of hydrochloric acid, concentration 1 mole per liter, required 50 centimeters of sodium hydroxide solution for complete neutralization. Calculate the concentration of sodium hydroxide solution. So let's draw out the equation first. So we have hydrochloric acid plus sodium hydroxide, and that is going to give us sodium chloride plus water. Acid plus base gives you salt plus water. Okay, and what I'm going to do is I'm going to set these out the same way for every one. And first of all, I'm going to put down the mole ratio. And I'm going to remember the triangle. Okay, so the triangle, I'll stick it up here so that we've got it. So that's number of moles, concentration, and volume. Okay, so just so that we've got that there. Okay, so I'll just switch back to red. And if we've got 25 centimeters cubes of hydrochloric acid, concentration 1 mole per liter. So number of moles is concentration times volume. We can say moles of HCl is equal to concentration times volume. Okay, so that is 1 mole per liter. That's 1 mole per liter times 25 centimeters cubed. Now that in liters is 0.025. It's 25 divided by 1,000. Okay, so what that means is I'm just going to put this in blue so that we can see this clearly. So I'm going to say moles. Okay, so that's different to mole ratio. Okay, and what I should have put in the mole ratio is 1 to 1 because it's 1 to 1. So what that means is if we have number of moles, if we have 0.025 moles of HCl, because it's a 1-to-1 mole ratio, we've got 0.025 moles of sodium hydroxide. So now what we can do is we can now calculate the concentration. So the concentration of the sodium hydroxide, NaOH, which is this here, we've got the number of moles and we have the volume because the volume is 50 centimeters. So the concentration is number of moles divided by volume, N over V. So that is 0.025 divided by volume, which is 0.05, and that gives us a concentration of 0.5 mole per liter. Okay, so let's have a look at this question here. So we have calculate the volume of sulfuric acid concentration 2 mole per liter required to neutralize 25 centimeters of sodium hydroxide solution, concentration 1 mole per liter. So let's draw out the equation. So we have sulfuric acid H2SO4 plus sodium hydroxide, and that will give us sodium sulfate, which is Na2SO4 plus water, Okay, so I'm just going to balance this and make sure that it can be balanced so that we know exactly where 2 goes there for the sodiums and then a 2 goes there for the hydrogens. So that's it balanced. So let's put mole ratio here. The mole ratio, so we're interested in the sodium hydroxide and sulfuric acid, so that's 1 to 2 this time. Okay, and I'll just pop in blue here, moles. Okay, so let's work out the number of moles of sodium hydroxide. So moles is equal to concentration times volume. Okay, so that's C times V, concentration times volume, which is 1. It's got 1 mole per litre, times 25 centimeters, which is 0.025. So that is 0.025 moles. Okay, so here we have 0.025. Now, if it's 2 to 1, that means if we've got 0.025 of sodium hydroxide, we've got half of the number, we've got half of that of sulfuric acid. So we have 0.0125. Okay, so now what we can do is we can now work out the volume. Okay, so the volume is number of moles divided by concentration. So if we've got our triangle, number of moles, concentration, volume. So volume is number of moles divided by concentration. So volume of sulfuric acid is equal to number of moles divided by concentration. And number of moles we have and concentration we have. Number of moles is 0.0125 divided by the concentration, which is 2, and that gives us 0.006225, and that's liters. Okay, so let's have a look at this last question here. So we have potassium hydroxide, 12.8 centimeters cubed of potassium hydroxide is neutralized by 25 centimeters cubed of nitric acid, 0.22 mole per liter. Calculate the concentration of potassium hydroxide solution. We have potassium hydroxide, nitric acid is HNO3, and that gives you potassium nitrate. Nitrate is a valency of 1, potassium is a valency of 1, so it's just KNO3, and that's plus water. Okay, so that equation there is balanced. Okay, so we can go mole ratio, and the mole ratio of potassium hydroxide and nitric acid is just 1 to 1. So we're now going to look at the moles and see what we've got here. So 12.8 centimeters cubed of potassium hydroxide is neutralized by 25 centimeters of nitric acid, 0.22 moles. So we can work out the moles of nitric acid. Okay, just keep this red. So the moles nitric acid HNO3 is equal to concentration times volume, and that is 0.22 times 0.025, and that gives us 0.0055 moles. Okay, so we can then go back up to our equation, and we can say if this is 0.0055, then so is this 0.0055. Okay, so because it's a 1-to-1 mole ratio. So now what we can do is calculate the concentration. So concentration of potassium hydroxide of potassium hydroxide. So got our triangle again. So it's number of moles, concentration, volume. Concentration is number of moles divided by volume. So it's N over V. So that is going to be 0.0055 divided by volume of the potassium hydroxide, which is 12.8 centimeters cubed, which is 0.0128 liters. So when we put that into the calculator, we get 0.43 mole per liter.